the true genius who invented Bluetooth. He let the earphones even without the cable bar. You can also hear music playing on your phone. It's amazing. So, how does it work? Answer first. The basic principle of Bluetooth transmission is to use electromagnetic bow in order to understand. Let's start with an example. When you walk down the road, you will see traffic lights in different colors. Traffic lights are actually electronic pops. They transmit information at different wavelengths. For example, the wavelength of the green light is about 540 meters. The yellow light is 570 meters. The red light is 700 nanometers. And our eyes. It's very easy to distinguish between these different wavelengths of light. The mind will send the light produced by these wavelengths. Translate the sentence as traffic signals in different colors. Something like this. Bluetooth also uses electromagnetic waves. Communicate between devices. Only, it uses another part of the electromagnetic spectrum. This part of the electromagnetic wave is about 123 millimeters long. We call it radio waves. These wavelengths are invisible to the human eye, and it can penetrate obstacles such as walls. Electromagnetic waves depend on wavelength and frequency. It can be divided into many different types, and you can see in the chart below. How do electromagnetic waves transmit information? We all know that numeric information is passed through binary zeros, unified representation. Therefore, we need to pass some way to distinguish between 0 and 1. Then a string of binary 1 and 0 are sent to the earphones and smartphones. It represents the unity of 0 by specifying the wavelength. For example, specify a wavelength of 121 millimeters to represent a, and specifying a wavelength of 124 millimeters represents 0. It's like the 540 nanometer wavelength of traffic lights is green, and 700 nanometers is red. The antenna of a smartphone generates these two wavelengths, and Bluetooth uses the 2.4 GHz band. This means, with its radio waves vibrating to 0.40 billion times per second, that's about 1 million zeros per second. Since sound is also composed of waves, therefore, when transmitting this information, the height of the wave needs to be converted to a coordinate value. Then convert these values to binary numbers, the number after the last binary. Transmission via Bluetooth band. Then if there are multiple Bluetooth device data at the same time, how to find the corresponding equipment and avoid interfering with each other. Pay attention. When two Bluetooth devices are brought together, they will first share a set of access codes and confirm the connection. That's what we call pairing. And then when the data is transferred, a connection code will be attached to the data. The receiving device can be confirmed with this code, and Bluetooth doesn't send all the data at once. Split into many small data packets. Each Bluetooth data packet contains multiple parts. So first, a 72-bit access code, used to ensure that the correct device receives the information, and then the 54-bit header. The content used to describe the information is 500 bits at the end. Get more valid data codes. In order to avoid mutual interference between Bluetooth devices, Bluetooth uses screen hopping spread spectrum technology. Specifically, it is to convert the actual frequency range of Bluetooth to 0.4 GHz to 0.483 GHz. This frequency band is divided into 79 channels. Each channel is unique and different wavelengths are specified. At any given moment, Bluetooth only communicate through one of these channels, and it switches channels 1,600 times per second. Therefore, mutual interference is avoided, and so that's how the data is transmitted digitally. Received through the antenna at the bottom end of the earphone, and then the Bluetooth communication chip on the circuit board, and audio processing chips. Convert to analog signal. These signals are relayed to January, the coil of the speaker. It starts moving by electromagnetic induction. Then the connected vibrating film vibrates, generate different shock voltages and frequencies, and that produces all sorts of sounds. Okay, do you understand?